first presenter is Sanne Hettinga.
Thank you so much. I'm going to tell you today about a project I've been working on, and the theme of today is machine learning. So I will talk about machine learning.
Could you please go to that side? It's better for the video. Otherwise, people won't see your slides.
Yep.
Yes, exactly. Okay, perfect.
So my initial thought was actually not to start with machine learning. I wanted to do mathematical modeling, just regular equations stuff, because I have a background in physics. And then, well, as I will present to you in a bit, that didn't quite produce the results we were hoping for. And then in our group, people were experimenting with machine learning in specific fields. So I thought, let's try it. And it gave some very interesting initial results. I have to emphasize initial results. This is I'm doing my PhD, and I'm looking at how we can use 3D data to enhance the energy transition. Just to give you a quick idea of why something went really well with the word stakeholders. So the idea is that 3D comes in many different forms. So we have data, we have models, we have visualizations, and in the end we want people to act on this process. And my PhD touches upon each of the three and how the three work together. And so this specific paper talks about mainly the models, but of course there's no models when there's no data, so the data also plays a role in there. So why the energy transition? So the European Union has just last week come up with a second installment of renewable energy targets, but they're not very specified per country, so I'm sticking with the 2020 targets for the moment. And the Netherlands has said we want 14% renewable energy in this country. And to achieve that in 2013, they came up with an energy agreement which laid out the initial plans of how to achieve this. And now they're working on a new climate law in which they want to enhance and deepen this idea. Just some figures. In 2016, the built environment was responsible for 32% of the energy consumption in the Netherlands. And of that, and the primary energy source the main primary energy source in the Netherlands was natural gas, closely followed by electricity from coal. And yeah, so the general outlook is still that we're not going very strong. We're at approximately 5%. A part of the other category could be counted as renewable, but we still have quite a ways to go. So we need to start planning for that, and to come up with good plans, we need good data to base our plans on. So for that, one of the built environment is being kind of regulated by an EU directive called the EPBD, Energy Performance of Buildings. And one of the measures in there is the Energy Performance Certificate, which consists of an Energy Performance Index, which is a calculation methodology that states what the net energy consumption of a building is. And this is made more accessible to the average human being by expressing it as an energy label. So in there you can see the table, conversion table. So A++ is a really good performing house. G is anywhere from badly performing to just leak as a basket. And based on these energy labels and the distribution of these labels within a country, a lot of policy is made. The Dutch building stock consists of 7.7 million dwellings. So this is only the buildings where people live, no shops, no industry, no factories, only houses. In 2007, 64,000 were built new. That means that there's a replacement rate of less than 1%, which means if you really want to get to these targets where we were just talking about, we need to start doing something to the ones we already have. Currently we have 2.5 million with an EPC, and a couple of them have, we changed the rules on how to get an EPC a little while ago, so it's become easier and cheaper to get an EPC. Before it cost you about 250 euros, which was kind of a hurdle for people. And an EPC needs to be acquired whenever you sell a building, when a rental house acquires a new rental contract, or when a house is newly built. Currently, this is the status of the 2.5 million certified buildings in the Netherlands. So on average, we're having a strong preference for a good old C label, but there is a semi-normal distribution, which is actually quite nice when you want to do machine learning, when there's a normal distribution. So these are only the modeled buildings, the known buildings, but that's only about 1/3 of the buildings that we have. So we decided to try to use some modeling to come up with the other 2/3 of the Dutch buildings. And we devised 2 models for that initially. Model 1, based on building typology. This is something that is also in the European Building Directive. It's called the Tabula data. It's from a project which is called Tabula. And Tabula contains for each country building typologies and potentially climate zones based on which you can model energy behavior of individual buildings. The Netherlands is so tiny, we don't have a climate zone, we just have a building typology based on building year and building type. The Netherlands is actually quite nice for that because we regulate so much in our building infrastructure that these are usually quite okay. This is what a page in the folder of the building typology looks like. And as you see, this is a freestanding house built before 1962, and it has an energy label of G. And based on floor surface area, which is fixed, everything is fixed, the type of roof and the square meters, they calculate the energy performance index, transfer it to a label, and suggest some energy saving methodologies to get it to a B label. Model 2, we thought, well, we can do that better because we know quite a lot of these things about a building specifically. We don't need to use everything from the typology because we know the exact surface area. We can calculate based on our height models. We can calculate the building envelope. We can calculate based on that the wall to window ratio and the actual window square meterage. And then based on these kind of tables in which the energy performance and indicators are very well described, we wanted to calculate it more accurately. Then we came to the initial results of the 2 models. So we looked at how many times we predicted the energy label exactly correct. And we came to, for model 1, 26%, and model 2, only 16%. This was, we had expected it not to be perfect, but this actually was a bit of a slap in the face. Especially because model 2 actually underperformed compared to model 1, which shows that you cannot add this accuracy. This is not something that the model allows for. If you go, you can say, well, you can go a label below or above, then the performance got a little bit better, so then we're 76 and 50% correct. But this is still not something that I would feel comfortable basing policy on. We were curious why it would outperform so badly, so I made...
A third is wildly off.
I consider, yeah, that's...
Right. 2 labels off is like...
Yeah.
Yeah, the difference between a B and a D label is really quite significant.
And what's the percentage of the C label?
Yeah, that was actually... that was 33%.
Okay, and of the B, C, and D together, do you know that?
No, I didn't calculate that one.
Just quickly doing the random baseline.
Yeah, I'm just curious what the...
Rijn told me about that one. And so the fact that if we just give everything a C and try it again showed better performance than our models, that was not really something we were very happy with. So we looked at what's happening here. And so what you can see here, so the green is still the actual label. And then if you look at the models, what you can see is that they shift quite much to the right. So, or maybe you don't, I hope you see it. If you don't, let me know. So we, in the actual labels, the performance is actually much better than in the other ones. Our model predicts relatively a lot, it's a touch screen. Predicts frequently a G label, or in the other one mainly an F and an E label as well. So this is interesting because our model predicts the buildings to perform much worse than they actually do in reality. So we started thinking a little bit, why might that be? One of the things is that
are the labels, the current labels that you use it to test it against, are they correct at all?
Yes.
Because I also understood that many labels were awarded sort of automatically, or you get
yes. So
by
these ones
default
we ignored.
Okay.
We only have the official ones that have an official EPC.
Right.
And these have been verified by the Rekenkamer. No, the Rekenkamer. So the Court of Audit. Thank you. By the Court of Audit, and verified that 86% of these are corrected, are completely
Correctly
correct,
labeled.
and the other 7% are 7% above and 7% one label below. And these were all, if you remember this table, they were all on the threshold. So it was in the one it was 0.69, in the other one 0.71. So it was really the accuracy of that one is quite good. The other one you're talking about is actually Model 1,
Right, and that
which
was
is
what
only
I was-
20% correct.
Yeah, that's what I was concerned. Then
Yes.
you have a bad way of
I
testing
had
the data.
several people asking me this question, and so the first issue is that the typology is actually from 2010. So the data was the building typologies were published in 2011, but the data was gathered in 2010, and we're now in 2018, and we had a lot of attention for the renewable energy transition and the energy agreement, which in which social housing corporate cooperatives in the Netherlands, which own quite a lot of the buildings, promised that they would have all the Dutch buildings to an average B label by 2023. So quite a lot of investment has been made in making existing buildings much more sustainable, and this is not captured in the new building typology. Furthermore, the sample is not representative. I've been talking to the cadastre and they analyzed the sample, and they say that in the sample are 90% of all the social the buildings that are owned by social cooperatives, and only 10% of the privately owned buildings. And so in the sample still out there, which we don't know, it's exactly the other way around. So we know mainly the performance of the buildings that are owned by social cooperatives. And for homeowners, there's only very little incentive to buy or take the time to apply for an EPC for improvements to their building, because they don't really get a payoff for it, and they only have to do it when they sell their building. So these are some of the reasons why we think it doesn't work out quite as we hoped. So then, sorry.
One more question. Are you convinced that the label is actually related to the energy efficiency of the house? I mean, somebody is calculating that.
I am convinced that they're related to it. I'm also sure that they're not 100% correct. There's a very nice study done in Delft that showed that the energy consumption correlated with the energy label is 20% higher than the actual energy consumption for the buildings that they tested. So it always overestimates the energy consumption. So the energy label itself is also a flawed label and a flawed methodology for policy, but it's what we're working with now, so I thought let's try to get that right.
Sanne, did you also plot, I mean this is SPINlab GIS, did you plot them on a map just to see if there's any sort of spatial clustering of the errors, because then you can see it's in certain neighborhoods, i.e. certain types of houses, certain cities that may have particular demographics more or less being inclined to sustainability.
No, I have not. I have looked at different building years and building types, whether they performed better or worse in general, and they did not.
Right.
But not on geographical components with census data, for instance. That is an interesting one to
Because
look
like
at.
there is sort of data from elections, or
Yes.
the polling stations, and there's, for instance, a band from Haarlem, Amsterdam, Utrecht to Arnhem of green left, GroenLinks voters, also certain house types.
Yeah, one of the things I'm
suburbs.
still working on is finding out whether for the privately owned buildings it performs better than for the social cooperative buildings, but that data is privacy protected, and I'm still working with the cadastre whether I can under specific terms use this data set. But that is a very interesting thing. I'll definitely look into that.
Okay.
So then to the machine learning part, it was the initial try that I've completed now is I do that with a colleague from Geodan, and so the methodology is not perfect. Rijn is helping me now to improve it. We used a random forest classifier, and we inputted a whole range of data for it to train on. So building year, building type, building use, which might seem similar to building type, but building type is specifically for dwellings, whether it's a detached house or a corner house or an apartment building, and building use is whether it's a school or a shop or a house. Total surface area, exposed parameter, and some neighborhood data that we consider relevant, though there might be others. So we did home ownership percentage and building value and gas consumption. What we need to improve on this methodology is we only use the random forest, but Rijn said that there's not necessarily one that's good for specific cases, so I should try several of them to see which performs the best.
When we get to that interruption, let me ask you.
I thought we had a question from
Somebody calling in,
It's coming from the arena. When you're looking at this, are you looking only at individual dwellings, or are you also looking at apartments in blocks?
The apartments are looked at, no, everything is looked at the address level at this
Households.
stage. Yeah.
So apartments in a block would
Yeah.
would be
It's one,
Individually.
they are all individually analyzed.
because they will have a very different performance
Yes.
than individual buildings. And when you were looking at your variables, it seemed to me that building density would be one of the things that may have a relevance, because the more dispersed the pattern of developments, the more energy dissipation is likely to be. The more concentrated and packed the dwellings, all other things being equal, you're likely to.
Yes.
So
Yeah,
that's why I was.
Yeah. No, we
Curious.
did try to capture, and I completely lost control now.
What is the exposed perimeter?
We have exposed parameter in there, and building, which is the volume to surface area ratio, but again, that doesn't account for the difference between detached houses and apartments. And the building type also differentiates a little bit, but the building density also is a very interesting parameter.
It was just.
I'm still experimenting a bit with the parameters that are, yeah.
So in the neighborhood data, you take building value into account. Isn't that largely also based on the label which a house receives?
No. No, the building value is the value that the government thinks should be paid for buying this building, which might be undervalued or overvalued. But there have been very many studies done on the correlation between building value and energy label. And there's roughly two groups who have made publications about this. So the economists who do regressions, and they attribute about 20% of a building's value to its energy label. And the psychologists and sociologists who do interviews and who find maybe like 0.1%, but usually no effect at all of the energy label. And there's been a very interesting study. If you're interested, I can send it to you. Done by a Swedish lady named Ms. Wallström, and she found some correlation, but it never exceeds 1% of the building value. And yes. So, and the mismatch is probably explained by instances such as that a beautiful kitchen and a nice bathroom also have very energy efficient appliances, and therefore it looks nicer and you're willing to pay more for it, but not necessarily because of the energy consumption, but because of and in economic regressions it's really difficult to include prettiness of a bathroom.
But isn't that?
I have been told.
Isn't there a very clear? It would seem like to me like there would be a very clear incentive. Like if a house is better isolated, you get I don't know in the first couple of years you get 20,000 euros less gas.
They find in psychological studies that this is not at all something that people are and so I've built a house not so long ago, and if I look at energy performance in my list and my partner's list of priorities, it came 8th.
Okay. Yeah. So I was talking with Rijn about this. So I can certainly understand that it doesn't influence your decision whether or not to buy. But it's very hard to believe that it doesn't influence what price you're willing to pay.
From the data itself, they're the real correlation cannot be found. And so if you also look at the psychological studies, people are just generally more interested in the prettiness of the bathroom, the location, and if you look at the current housing market,
but
this
that's
is even
that's
more
the
horrible.
buying decision. So to buy or not to buy.
But
for
also
how-
the price you want to pay for it. Usually that's more based on how much your bank allows you to spend than.
Okay, let's go.
Yeah, sorry. Very interesting discussion to have later. So we are going to test a range of classifiers. I understood initially that for these a similar case they used the random forest, so I thought that I should use, but that's not the case. And then we had a bit of a wrong distribution of data. So now we're going to change that to have a very big training data set and limited testing validation data. And I'm going to optimize the hyperparameters because now we used a fixed number of trees, for instance, and that is not necessarily the best number that we used. And the results, wait, I made a table somewhere. I lost a table. Anyway, the performance of exactly correct predictions was 67% for this initial machine learning model that I used. And when you allow one label to be off, we get close to 90%. So actually for a first and slightly flawed methodology, we thought that these results were very, very promising, and they showed much better performance than the initial two only geospatial-based models. So in future research, I want to include additional parameters, and I had some very interesting suggestions today. And we would very much like to try this as well for other European countries, because the fact that the building typologies from the European Union are performing so poorly for the Netherlands might be an anomaly, but it would be interesting to see and relevant to see if it's something that's underperforming for more countries. And we want to use more specific building information from BIM models. This is a standard the architects use, and a lot of the building performance parameters, such as the insulation value of windows, is something we cannot get from geospatial data, but are included in building information model databases. So if we can include that in the model, then we know very much more still. So
Sanne?
yeah.
In terms of future research, I know the department also has the Funda data, right?
Yes.
NVM, so all the house transactions with what I gathered, all the variables listed in the report, assessment of the house. That's not what you use in your research, right? You
I have not
didn't
used
match
it
the
yet.
two, like
No.
a lot of high level detail on the house, what level, and then you know things like insulation or the kitchen, pretty kitchen.
That is not included in the Funda data. And
Okay.
so what I really want to know is now we're getting very technical, but this window is double glazed. That
Right.
sometimes can be found still in there, but there's a high range of different double glazed windows. So some
Right.
double glazed perform better than triple glazed because they're just high quality, and some double glazed are just marginally better than single glazed. And so
Right.
this is something that you only really can find in building information models.
Mhm.
But it definitely, there's some additional parameters from the NVM data set is something I would really like to use.
You're talking about BIM models, but wouldn't those be available only for new build?
Yes, at the moment it is.
So basically, for new builds, you pretty much know what, or likely to know what the energy
Yes,
label is.
but they also already have one, so these are.
But probably the most interesting questions are about the older stock rather
Yes.
than the new stock.
Yes.
So I don't know about this Funda database, of course, but is there any data from estate agents that you can get?
This is exactly.
That's actually
Yeah. No, and about the building information models, we've been working for a very long time to find someone who has access to this data, and it's difficult, but we have just done a project with the city of Amsterdam, and we're looking in progressing this for specific buildings to have these building information models gathered for existing buildings at the moment. And I'm also talking to some builders who also have some of these building information models from before and after renovation projects they carried out. So this is really new research because it's really difficult and not very present, but I felt that it was a very nice challenge I wanted to take on. So, really quickly, the conclusions. Modeling using the building typology is not really what we hoped it would do. But machine learning does show very good promise, but I'm very aware that my methodology needs some good further development before I can say exactly what the promise is here. Thank you.
Oh, sorry,
Yeah,
no,
please.
Did you get a look at what's here then?
Yeah, I read the paper. It was,
Yeah, we read the paper.
Very nice.
Oh,
So I was curious about this distribution, the distribution of the houses for which you have an EPC rating.
yes.
Do you know how likely that is to be biased? What the sort of sampling bias is? Is
No.
the population of houses for which we have a rating very different from
No,
the rest of the Netherlands?
there's currently a study being performed by the cadastre in Zwolle,
Okay.
where they're sending people to, they're doing subsetting, and then they find the buildings that are not, and they are doing a quick EPC analysis,
Okay.
but this is still being carried out. But the feeling is that it is a bit biased.
Well, okay, so long as you know
Yeah.
the bias, then
Yeah.
that's sort of step one.
This is about energy transition,
Yes,
so it's about energy consumption.
yes.
Did you consider just letting this loose on gas consumption only? I mean, sometimes adding more data is only adding more problems instead of, so it might have with just the energy consumption, you might have a better relation than with all those areas and exposed.
One of the things that when I get the model to work correctly, I want to run it with individual parameters to see the sensitivity of the
Right.
analysis. But the disadvantage of the specific energy consumption data that we use is that we do not have it for the individual building or the individual address. We have it averaged out over a certain number of buildings, again, due to privacy.
Postal code?
Postal code, yeah.
Right.
So if you're very lucky to have it, the minimum number of buildings has to be 7, but usually it's around 50 buildings per postal code, and the difference between one neighbor and another can be 3x, for instance, and that's quite significant, and therefore we try to balance it out a little bit as well.
So to continue on that point, you indeed have a lot of predictors at the moment,
Yes.
and you downplay your conclusion with the methodology needs further development, we need additional data. But to be honest, if the results are what I see, 99% is already a great result, of course. So
No, 67.
67?
67.
But in the end you got 99.
Yeah, if it's one,
Yeah,
one.
This one is.
Ah,
This was
okay.
deviation from the lake.
Yeah, so by the time
Does
you
it
get
again?
my level,
You should stop doing that. So
Oh,
from
Okay.
when it can deviate around 3, then we're really happy. But that's as we
Too
said,
much, yes.
that's too much.
yeah.
And so one of the things that we misinterpreted in the first stage was we thought it would be very nice to have it test on a lot of data, not train on a lot of data. So we used so where we now want to have the bulk in the training data, now we have the bulk in the test data. That is when you have people who are new to machine learning might have a small misunderstanding. So we needed to train on more data first, and I think that already will help a great deal.
Okay, I think we have to move to the next speaker.
Congratulations.
Thank you.
No.
Je moet mij dus best een koffie pakken, dan kan je het maar eens denken. Gaat het niet net van?